Hello everyone, today we'll be going over the concept of data locality in our system design course. And so to be able to help us get a deeper understanding about data locality and what it means, when we talk about data locality for queries in databases, we're referring to how data is organized and stored to optimize access. Over here, how data is stored to optimize access. Imagine a library where all pages of a single book are scattered across different sections. Every time you want a particular chapter, you have to search the entire library. This is akin to data being split across multiple tables in a database. However, if the entire book is in one section, you save time. This is the essence of storage locality in document databases, where documents are stored as a single continuous string in formats like JSON, XML, or BISON. Or BSON, sorry. So, document, databases, single or set of strings in document. Such as JSON, XML, or BSON over here. And so for our given example, I'm just going to zoom in. We have a JSON file that we have. We notice that we have the strings that are already set up in place, and they are organized accordingly, and this is for an LSAT application. So this is a JSON file to be able to start with. And the advantage of this approach is significant when your application frequently requires access to the whole document, like rendering on a web page. Here, having all data in one particular place means fewer index lookups and disk seeks, leading to faster performance. Yet, there is a caveat. This is only beneficial if you need large portions of data simultaneously. Only beneficial needing to see large portions of data simultaneously. Databases usually load the entire document if only a small part is needed, which can be inefficient for large documents since the database is not the data is within the database and you're taking a device and you're connecting to the database. However, with data locality and with document-based models, the data is stored locally on the device you're using. So, in of itself, when you have an app that you already download on the App Store, and it has documents already associated with it as a document-based database model, those documents are also downloaded on the app, so it's all local, and you're able to have faster lookup times since the data is already right there. Moreover, there is a bit of a tricky situation when it comes to document databases. Updates can be tricky. If a document size changes due to an update, the whole document needs to be written. So if you want to add a particular field, you're going to have to spend a lot of time, in particular, getting through this entire JSON file to be able to update every single component so the data is showing inside of the application or any other piece of software that you're actually using. The whole document Hence, the best practice is to keep documents small and avoid size increasing updates to leverage storage locality efficiently. The notion of data locality isn't confined to document databases. Relational databases have begun to adopt similar concepts, allowing for schema designs that nest related data closely together to gain similar advantages in data retrieval efficiency. Convergence of these models, both relational and document, is the industry's response to varying data storage and retrieval needs. Relational databases have started incorporating features to handle XML and JSON, blurring the lines between them and document databases. Meanwhile, relational databases have been incorporating components of document-based models. I'm just going to put in such as handling features of XML and JSON. Meanwhile, document databases have introduced capabilities for relational-like operation, like joins. Document models implement relational database components. This convergence benefits applications, allowing them to choose the optimal feature set from both worlds, depending on their specific requirements. A hybrid approach, I'm just going to put in the definition right here. A hybrid approach combines the strengths of both relational and document models, appears to be a promising path for future database technology. A hybrid approach combines both components of relational and document database models. Hybrid approaches provide flexibility and performance optimization for a wide array of applications, ensuring that the storage model can be tailored to the specific needs of the data and how it's accessed. So, hybrid provides performance and flexibility of data retrieval and processes. So if we want to go over our notes, namely, let's clean some parts of this up. Components of document-based models. Okay, so relational and database and document databases. I'm just going to clean this part up so we already know what we're talking about. Document databases. So this is called the hybrid approach in our given example, such as put in the joins example that we talked about from document-based models right over here, ex joins, and public and private over here, our JSON file. I'm also going to be, let me just underline this part. There we go. And so, yes, this is our concept of data locality. Let's move over to a concept example. So to be able to go over our concept example of data locality, let's look at an example of a blogging platform. And in this blogging platform, we are considering where each blog's post is a document. Each blog's post is a document. Users can read, write, and update posts, and if the platform uses a document database, each post might be stored as a JSON object. Each post will be stored as a JSON object. We're doing a document database, which includes the title, content, author, and comments. When a user opens a blog post, the system retrieves the JSON object. Because of storage locality, the system fetches all the information in one go. Fetches all information in one go. Therefore resulting in a swift display on the user's web page. Now imagine that the platform includes a feature allowing users to add images within the post. Feature example. Add images to the post. If these images are small and embedded directly in the JSON file, it aligns well with the recommended practice of keeping documents small. But suppose a user adds a very high resolution image that significantly increases the document size. In that case, the performance advantage of storage locality can be diminished, as updating the document now requires rewriting much larger files. So when we add images to the post, make sure the images are small, easy enough for the JSON file to handle. Easy enough for the JSON file to handle. If too big, need to rewrite the whole JSON file. If the blogging platform were to move to a hybrid model, the text content of the blog could be stored in a document database for quick retrieval, while metadata, authors, and comments could be stored in a relational database, allowing for more complex queries and relationships. So let me put in hybrid model, basically best of both worlds. Use quick retrieval of document use quick retrieval of document databases while storing larger files in relational databases. Therefore, creating an ever-expanding dynamic-based data-intensive system to scale with large amounts of data. And so yes, here's our concept. There we go. Let me just move this over here. And so, yes, this is our concept example for creating a blogging platform that can handle large amounts of data. And we also focus on the concept of document models and relational models and how to create a hybrid model as well from a conceptual overstand view. Now, to be able to solidify our concept, let's go over a practice problem. Consider an online bookstore application, and the system must manage a large inventory of books, customer orders, and reviews. And for any data-intensive system that we have, it's always going to need a database, cache, and queue. A document database is used to store details about books and reviews. So a document database stores details of books and reviews. And meanwhile, a relational database manages customer and order information. Manages customer and order information. So a cache is employed for quick access to book data. A cache used for quick access of book data and a message queue handles a stream of incoming orders. So the queue manages the stream of incoming orders and what we need to do is to be able to showcase the workflow for actually understanding the interaction with getting the book details in the document database, understanding how to get the customer data in the relational database, and the other processing through the messaging queue. Additionally, we need to consider failure points to highlight any faults that may lead to failures from the hardware, software, and human side as well, such as a database going offline, and how will the system maintain consistency and recovery over the events. So to be able to give an overview, we're just going to go over 3 different steps or 3 different entities to be able to go through. 1, we always need to identify the key relationships. And as highlighted already before, we have a database cache and queue. And with the database cache and queue and how they're all managing to work together, let's list out all of the following components that we have. So we have a document database, relational database, cache, and queue. Since these 2 are technically the databases that we have up here. And to understand how each of them actually work all together, we need to understand the relationship for how, since we have 2 different forms of databases, how are they going to match up? Well, to give the overview, the document database must be queried to retrieve book details, since we already know it stores details of books and reviews. So if it's going to be stored, that means we're going to have to put queries to get book details and reviews. And that means we need to actually update consistently with the cache to have the information already there and present. And that information, since it's already there and present, the document database is going to store that information in the cache. So book details are stored here for quick retrieval. Because in document databases, since we are given a set of strings that we already have within our document, and it's beneficial to be able to have all the information there and present within our application, it makes sense to be able to have the data already present on the queue for quicker lookup times. And then meanwhile, the relational database is queried for customer data and order information. So queried for customer. Let me just get rid of this part. I just needed it for a bit of a placeholder. For customer, let me just move this over here. And use a different color as well. Queried for customer data and order information. And since a queue manages the stream of incoming orders, the relational database is also coinciding with the queue. For the queue manages the order processing via a message queue. Then step 2, illustrate the data system. And to give that overview, namely, what would happen is that we'd start with customer first, placing the order. The system, querying the document database, for the book details, checks the cache, then retrieve the customer data from the relational database, and finally process the order via the messaging queue. Let's just underline that red. Also cache, so we already know, because every data intensive system is always going to have a database, cache, and queue. Over here. And then finally, for our third step, we always need to figure out how to handle faults and failures. Handle faults and failures. And so within our workflow that we already have to handle the faults and failures, we can just go through the entire walkthrough that we already have, and we can pinpoint different faults that may occur from a hardware, software, and human standpoint. So looking from a hardware, software, and human standpoint. We're going to go through our workflow diagram. See the faults. From each step to mitigate failures. And implement protocols. Implement recovery protocols for each step. And yes, from all three of the via hardware, software, and human side. So again, we would just pinpoint different faults and failures that we'd have. I'll just use a different color over here to illustrate the point. So we could have see the faults, see the faults, see the faults, see the faults, see potential faults, to mitigate failures, from hardware, software, and human side. Let me just go up and scroll up to see if we have it. Let me just move this over here for you folks. That way you could be able to take a screenshot of these notes, making it more efficient. Let's move the third one over here. There we go. That's better. Just gonna clean up these notes over here. That way you would be able to there we go. So yes, going over the whole system. This is just the practice problem 1 walkthrough. Now, to be able to further solidify it, let's look at our second practice problem. So in this one, we're going to be building a corporate management system. So namely what we need to do in this one, imagine that the corporate management system handles registration schedules and participant feedback. What we will be using is that we will be using a document database. Oh, sorry. Relational database, since we are creating a hybrid, data system, and also every data system is going to need the following: a database, cache, and queue. So in our document database, we're going to be using a NoSQL. Which is best suited for flexible data storage of event details and participant feedback. And meanwhile, the relational database maintains registration and scheduling. Maintains registration and scheduling. Meanwhile, the NoSQL event details and participant feedback. Meanwhile, the caching system that we will need provides instant access to the scheduled data, and the messaging queue is in place for processing feedback and updates. Back and updates for the messaging queue. Well, meanwhile, the cache instant access to scheduled data. And yes, that cache is going to get that information from NoSQL. NoSQL database. Meanwhile, what we need to do within our given problem is that we need to develop a scenario where a new feature allows participants to sign up for event updates. So that means a new feature allow participants to sign up for event updates. And we need to configure and work through the data flow and interactions to implement the feature. And we need to consider how registrations are tracked, schedules are updated in the database, along with the cache system reflecting these changes, while addressing what happens if an update process is interrupted and how the system handles particular failures to avoid miscommunications or data inconsistencies. So that means what we need to do, namely, it's much like identifying, like, once we already build out this new feature, how is it going to fit within the new database and the whole data system. So what we need to do first, as usual, is identify key components, and relationships. So namely, every data system is always going to have their database, cache, and queue. So we have a hybrid database with a document and a relational. Well, and then also we need to figure out how the relationship matches up the cache and the queue. So going back from our previous example, we already know that the document's always going to be related with the cache, and meanwhile the relational is always going to be related with the queue. Since document, as stated before, already focuses on event details and participant feedback, while relational databases maintain registration and scheduling. So going over here, document. Well, to break down the following feature, what we need to do is that since we are focusing on participants, we will have participant feedback. as stated over here. Yeah. Well, the relational database focuses on scheduling. The cache showcases access to schedule, and then the queue always processes updates for both feedback and scheduling. And so just highlighting the entire relationships between them. Next part that we do, workflow, understanding, POV, so what we have is that first, whenever there is a new feature being added, allowing participants to sign up for event updates, so what we would have is information from the relational database is updated with the participants' registration, that is updated in the messaging queue, and then sign up triggers, an update in the schedule, both stored in the, if we go up, since we already know the document database focuses on the event details, and since caches are already connected with the document, schedule both stored in the cache and document database. And so yes, I'm just gonna put it right here, cache, queue, relational database, and the document database. So we worked our way from previous, since we had to divide up between exactly how each component would flow through in the relationship if we were to give a point of view perspective. And finally, the third will be handling faults and failures. From a hardware, software, a human side, looking at each of the steps from our workflow that we have from the beginning, middle, and end over here. Highlight all faults. All faults which can lead to potential failures. There we go. So let me just move out here to showcase. There we go. And so, yes, this was practice problem number 2, and this was our video on the concept of data locality and hybrid databases. Thank you very much for taking time to be able to watch this. If you found this helpful, be sure to, and feel free to, like and subscribe. If you have any other questions, feel free to put them in the comments section. And as always, take care. Cheers. Bye-bye.